What I'm going to try and demonstrate with this video is basically I've got a video of a screen video of my car driving down the road, and this gives you some sort of idea of how the map works, how the fueling works, as far as the VE table, the fuel map. It's called a VE table for volumetric efficiency. The theory is that the numbers will show you the volume, as long as you set your required fuel level up and everything else is equal. This should, and your injector opening times, etc., this should show you the volumetric, or this should be the volumetric efficiency of the engine. Don't get hung up on it too much because they're just numbers, but the main thing is they're within a reasonable scale. So like mine goes up to 135 and down to about 35, 40. That's a reasonable scale. If you're up in the regions of 240, 250, then you can say to yourself, I haven't set the required fuel up, because the required fuel is multiplied by these values, and it comes up with, as well as other corrections, but it comes up with the how long the injectors are open for, so therefore the amount of fuel that's injected into the engine. This is basically a mappable section of the ECU as far as the fuel maps goes. Down the left hand column here we've got engine load, which in my case is speed density, so 100 kPa is atmosphere. Anything above 100 kPa is boost. Anything lower than 100 kPa is vacuum. So when the engine's idling or just running normally, it'll be somewhere down here under 100, depending on the cam you've got and all that sort of thing. But mine roughly idles about 55 kPa. If you and we'll go up to 150 psi boost, or 140 actually, but 150 kPa of in boost. So that's 150 kPa is basically just over 7 psi of boost. So I think I go up to about 140, which is 6 psi. If you're speed alpha n, this would be 0 to 100%. And what I would tend to do, I'll have to show you a speed density map, but if you had a speed density setup, you ideally want to be setting a lot of your bins, a lot of your tables up so as you've got low throttle position to start with. So you ideally want to be setting quite a few of the first bins up, the first columns up at low throttle positions. So let me connect to Megasquirt 2. It's the same sort of thing in theory. So this is a throttle position based fuel map. Throttle position down here, engine speed across the bottom. So let's just set this up so we're idling. I'm just on a stimulator at the moment, but it's very important on an alpha N setup to set up as many bins as you can at lower throttle. It depends on whereabouts you drive most out. I mean, you may find that you spend a lot of time at 25% or 20%, so you may want to set these bins a little bit different depending on what sort of speed or what throttle position you are at when you're cruising down the motorway or cruising at normal speeds, whatever. So it's difficult to know exactly where to set these, but generally speaking I tend to set up quite a few low down, and then you can start stepping it up. Once you get 95% is as near as damn at 100, so this, you're not going to need very many up here above 50, so 60, 70, 80, you haven't got to do it in 5% steps or anything like that. So as long as you carefully put them, I mean, the MS2 map is massive, so you can see look, these ones here are virtually the same. That's all the way around. So you've got 3 bins, 3 rows here, which 4 or maybe 5 you could have got rid of. So and the chances are you're never going to drive it at 85% or 75%, and even if you did, that'd interpolate between them anyhow. So anyhow, that's just an idea of how to set your throttle position map up, and how that works differently. So if I increase and decrease the throttle position, that's engine speed, sorry, throttle position, you'll see it going up and down. And at RPM, if I decrease RPM, now the yellow bits around it, if I try and get up, if I try and change one of these to the value, nope, what do I want to change it to? Okay, this is the current value that is running, that's calculated from this table. So if I take the throttle position up a little bit there, so it's run the smack bang in the middle of them two, so in the middle of two 55s, and you can see that is 55. Now the yellow area, the blue area is exactly where the engine's running, so it's running at smack on between them and at that throttle position or engine load. The yellow area is roughly saying how much, you can see if 55%, 41%, 1% and 1%. So it's running 1% of that bin, 1% of that, 41% of that and 57 of that. So, and the calculated value from all them bins, so it interpolates between the 4 bins that's around it and comes up with the actual value that is used in the fueling calculation, the VE current. So as you can see, if I increase these two, that will affect the fueling. Maybe not much because we're not at that point, but if I increase throttle position a little bit there, if I increase these two, that's going to affect the fueling, which is your pulse width. So, but equally, if I alter these two, that'll affect the fueling. So just bear that in mind when you ever do any tuning. There's not just one bin at a time. You've got to sort of blend them in. What I tend to find is that if you'll know if you're miles or if you're starting going wrong, because the map should slowly increase in that way. The numbers should slowly increase in that direction, and they should also slowly increase in that direction. As you can see, the my numbers not set in stone, but they almost always increase there and increase in that direction. So over here, a low throttle position, 4, 5, 6,000 RPM, you're never going to drive there. Well, you might do, but chances are you'll never drive there, so you'll never tune that. So when you get up to it, say, you know, if you only ever got to say 2,500, 3,000 RPM at light throttles, then you need to increase your throttle in order to get up to this RPM. What you can do is just increase this value here, or if you finish at 50, say 3,000, you never go into that. This value here, 55, just make them all 55 or thereabouts, you know. Try and leave them roughly around the area. Don't end up with values here wildly away from where you've ended up tuning it. Just keep it neat and make it look nice. So I mean, if you end up with 1s and 2s in here, then you're going to have no fuel going in at that point. Not that you'll ever drive there, but you never know, you might do for some reason or other. It's very difficult to know how far you're going to, whereabouts you're going to tune the whole thing, because some parts of this map you'll probably never touch. Well, you'll never touch full throttle at 750 RPM. Well, highly unlikely anyhow. So anyhow, that's the idea of the fuel map. So now if I just show you, I'll just show you in 3D mode. I can highlight one. I can highlight a map. I can drag it up and down with my mouse if I want to. I can use the arrow keys to move it up and down. I can press F and it finds the nearest bin to where the actual engine is running. You can do all sorts of things, and you can F again to unlock it. You can move the map up and down if you want to, you know, so you can see it differently. But as you can see, if there was if you look at it and that you saw that, then clearly in that point there, you can see that there's something drastically wrong here. If you had just grab on another one, peaks and troughs like this all over the place, then your fuel map's miles out, because you know the engine won't run like that. That's not a true well-tuned map. If you've got bits and pieces all over the place, that should look reasonably smooth. Don't get too worried about it, but because as your cam comes in, you will find that these increase as well, so don't worry too much about it. But if you've got massive spikes and dips in it, then that's not quite right. You can see these numbers I've altered. They've changed colour. The blue means that the numbers increase, and if you hover over it, it actually says that beginning value was 80, so that was 80. So if I now go equals 80, it goes back to where it was. 24, that was 88, so 88, 70. Again, you could do it on the 3D direct thing if you want to. Just grab all the right bit, just bring it down, make it smooth, just smooth the map out. Just by doing that. But the numbers themselves are all to do with the you need to tune this with your wideband lambda sensor, and but I've just given you some idea of how the VE table works and how it follows the engine. So if I just open my little video, I'll just shut this down for now. So if I just go back to my little video of me driving down the road, you can see this is not throttle position, it's engine manifold pressure, but it is related to throttle position. And that's the three-dimensional map, following the three-dimensional map. So you can see it going down the road and accelerating. As it decelerates, I pull because of map. If I decelerate again in a second, I'll show you. But the map dips down here because it pulls a bigger vacuum when you decelerate. Okay, this is the VE analyzing software, which you can purchase through Tuner Studio from Phil Tobin. It's very, very good stuff, but it's not without its issues, in that you can't just rely on it. You can't just click on auto tune and away you go, because this will only tune the areas where you're driving. So at the moment it's driving between them four areas, like I explained earlier. That's the from those four bins, it's going to calculate the VE number for the fueling calculations, and if it's say lean, say at the moment I'm running at 13.9 AFR, so it's a bit rich, and the chances are I'd want to be running at say 14.7 for argument's sake. So this is going to follow the VE the AFR target table that's within the settings, and this will look at that AFR target table and say, right, we're running at 13.9 from the wideband lambda sensor. We want to be running at 14.7 from the AFR target table. So we need to decrease these numbers in order to reduce the fuel, so the air-fuel ratio comes down, becomes leaner. So it'll start decreasing these numbers, which is fair enough, was what you want to do. But it may reduce these numbers to underneath. It won't affect these ones around it, but it may start reducing these numbers drastically, and the ones around it will stay still at the moment, and they may end up lower than these numbers, because the chances are you may not drive at that point there for a little while, or while you're auto-tuning, or you may never drive there. Or the next time you drive there, say for instance you're driving halfway in between, it's leaned these ones out below 59, so say for instance it brings this down to 57 for argument's sake, then that one's 59, and that'll go, oh, I'm still too rich here, so it'll reduce these two. So it'll bring this one down, which was 57, now to 55 for argument's sake, and this one down to 57. Next time you're up here, that'll go, oh right, bloody hell, I'm still running I'm still running rich because this one's, or lean, I'm too lean now because this one's too rich, and it'll increase them. So you've got to be careful how you use this. What I tend to do is I run VE, I get the map very close, then I'll use this and I'll see how much it tries to alter it. If they're altered blue, then that means they've tried to increase them, if I remember rightly, and if they're red, it's tried to decrease them because they're too rich, it's tried to decrease the number. And I'll look at whereabouts it's done it. Now, if it's put a big hole, if it's brought all these numbers you can see are sort of nice and smoothly increasing and decreasing, if it's brought that one down to say 50, and all around it is 55, 60, then you know that what you've got to really do is bring all these numbers down a little bit, put that one back to where it was, and bring all these down a little bit. It's not a fine art, but there's quite a bit of experience and knowledge to do all of this. It's not just a case of running this software and away you go. It's a bit of an art, a bit of guesswork to get it sort of reasonably well tuned. Not guesswork, that's the wrong word, but a bit of you have to play with it and just see. You fine tune it a little bit and then see where it goes, and fine tune it a little bit more and see where it goes. I tend to do sort of 5, 10, 15 data logs using this and seeing what it does and try and get a sort of idea of what it's trying to adjust. But just see how you get on with it if you want to pay. I mean, I think it's about $50 or $60 to pay for it. It's very good, but just be careful how far you allow it to move. Let's see where we go next. You can see it decelerate, go through there. That's cruising down the road. I actually want the AFR 14.1 at this sort of engine speed, so that's roughly right, 14.1. It will fluctuate a little bit. I have 14.1 stop at hunting. Idle. Okay. As you can see, my idle, if I just rewind that in nats, you can see my fuel load is fairly constant, 55, 56 at idle. Let's get rid of him for a minute. A bit preempt. Yeah, 55, 56, my idle sits around there. Sometimes on speed density, you'll find that this will jump up and down and left to right in speed density mode. As the engines sort of, sometimes they cannot be, it's very difficult to get a nice stable idle in speed density. In Alpha N you haven't got to worry, because in Alpha N you'll only use one or maybe two parts of the map, because if you set your fuel table up for 0, when you take the foot off the throttle it'll go to 0. It won't use these because it's only there. So if the RPM comes down to your idle RPM of, say, I don't know, what we're going to have, let's see what I can get this twiddled to, 900 RPM for instance, it's using 13% of that value and 87% of that. So if I had an idle RPM of say 850, setting one at 900 is quite, or 850, will hold me within that, so I haven't really got much fluctuation there, because it isn't going to go up and down with engine map with the manifold air pressure. There's going to be no fluctuation, so setting a nice idle up with throttle position is very easy. To do it on speed density, I'm up here in this map and that could fluctuate a little bit. So what I tend to do is like the area around idle is this area here. I set a couple of rows up. My idle's 800 for instance, 776 it is, but 800. So I'll set a bin up 100 before, lower than that, and a bin up 100 higher than that, and then I'll make all that area the same value. So whatever happens to the map, if the map fluctuates up and down a little bit, the fuel VE type VE will be calculated at the same. That'll still be the same. So if that fluctuates up and down a little bit, that'll always be 46. So the fueling itself won't alter too much, and that does give you a more stable idle. I've got a row here of 500, mainly because before some of the features were added to MS3 and MS2. It was handy to have a row in here to richen this up. If ever the RPM dipped below 500, or if it started dipped below 700, that'd go into this area and richen it up. But things have changed a little bit, and I'll explain that later. But I've kept that in there because where am I going to add it? I mean, I could add another row in here somewhere, shift them all left, and add another one in. But I mean, to be honest with you, this table is massive, and some of these rows I could get rid of if there's no need for a table to be this big. I mean, these ones here are all virtually the same, so there's no need for me to have had that bigger table, but that's there, so we've got to use it. So anyhow, but with MS2 you can do that, and MS1, MS3, they're all the same. But with MS3 now they've added an idle VE table, which is here. Now this allows you to have a separate little table at idle.